Hello everyone, and thanks for watching Edupedia World videos. In this video, we'll discuss solutions to problems in paper 2 of the 2013 JEE Advanced Maths question paper. I'll be following code 0, but in any other code, the problems will be the same, just shuffled around, so you can figure it out for yourself. I'll start with problem 41, which in this paper has omega being a complex cube root of unity and P is equal to Pij, an n cross n matrix with Pij is equal to omega to the power I plus j. And we want p square to not be equal to 0. Right, so let's just write down this general matrix P for a certain number of terms. Right. So this would be first row, first column, omega to the power 1 plus 1 would be omega squared, then 1 plus 2 omega cube would be 1, then omega squared 1 omega dot dot dot, like this. Here also, this would be the second row, first column, 2 plus 1 is 3, so 1 omega squared 1 omega dot 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 dot. And just like this, the pattern would keep on repeating. This would be 1, then this would be 2 plus 2, which is 4, which is 1, so omega squared 1 omega. Like this, the pattern would go on. Right, this is P. Now if you wanted P square, you would multiply this by the same vector, by the same matrix, omega square 1 omega square 1 omega dot dot dot, 1 omega square 1 omega dot dot dot, omega square 1 omega square dot dot dot. And this is an n cross n matrix and this is an n cross n matrix, so the product will be an n cross n matrix. What is the first row, first column of this matrix? The product of the first row and the first column. What is that? Omega square into omega square is omega to the power 4 plus 1 into 1 is 1 plus omega into omega is omega squared plus, and now the terms keep on repeating, omega squared 1 omega, this triplet keeps on repeating, and here also this triplet keeps on repeating. So plus omega to the power 4 plus 1 plus omega square plus this same triplet again and again. But what is this triplet? This is equal to 0 because omega to the power 4 is the same as omega, and 1 plus omega squared is 0. This is a property of the three cube roots of unity. Right. So this is equal to 0, and let's say there are 10 terms. Then 9 of those terms will form triplets and the 10th term will be the single term that is left. Right. Similarly, let's just look at the second row and second column for a second. This one and this one, that will have the same thing, 1 into 1, omega into omega square into omega square added up. Every row will basically be of the same form, 1 omega and omega square, or rather 1 omega square and omega to the power 4 added together, and those things being repeated. So only if n is equal to 3k, that is if n is a multiple of 3, all these triplets would be 0. Right? If n is equal to, let's say, 6, then you would have just this. If n is equal to 9, you would have another triplet which would be 0. If n is 10, then you would have 9 terms which would add up to 0 in groups of 3s, but one term would be left, so the entity would be not 0. So if n is equal to 3k, then for p square, every term will be 0, which means p square is equal to 0. So we want p square to not be 0, that means n should not be equal to 3k. 57 is the only option that is a multiple of 3. So for the other three options, p square is not 0, which means they will be the answer. So it is B, C and D. Now this 42 is a standard absolute value problem, and you do it by the most standard way possible. You just remove the modulus if the term inside it is positive, and you multiply it by 1 and remove it if the term inside is negative. So we are given fx is equal to 2 mod x plus mod of x plus 2 minus mod of mod x plus 2 minus 2 mod x. Right, so we'll try to calculate in a few regions. Let's look at x is equal to 0 and x is equal to minus 2. Right, because those regions determine the modulus. So what if x is 0? If x is 0, fx is equal to 2x plus if x is 0, if x is greater than 0. X greater than 0 means mod x is x and mod of x plus 2 is x plus 2. Minus mod of x plus 2 minus 2x, which would be 2 minus x. And then you have fx. Now we'll take minus 2 less than x less than 0. So in this region mod x would be minus x, so minus 2x. But 2 plus x will still be positive in this region. So plus x plus 2 minus mod of x plus 2 plus 2x. Right, which is basically 2 plus 3x. And for x less than minus 2, we would have both the moduluses would be replaced by its negative. Minus 2x minus 2 minus x minus mod of minus 2 minus x plus 2x, so minus 2 plus x or x minus 2. Now let's try to simplify them wherever we can. Mod of x minus 2 will always be negative for x less than minus 2. Right, so this can be written as minus of 2 minus x. Right, or you can just write it as plus of x minus 2. So this becomes minus x and x cancel. So you have minus 2x minus 4 or minus of 2x plus 2, or let's just write it as minus 2x minus 4 for now. So this branch of the function is determined. We need to do it for every branch. Then we'll be able to solve other things. We don't even need to solve it, then we can just make a graph. So for x less than true, this is true. Now between between minus 2 and 0, this term takes two values. Right, this is 0 if x is equal to minus 3 by 2. Right, so this has two sub values, minus 2 less than x less than minus 3 by 2 and minus 3 by 2 less than x less than 0. For minus 3 by 2 less than x less than 0, this term is positive. But between this region, this term is actually negative because minus 2 by 3 and minus 2 by 3. Yeah, x is minus 2 by 3. So x is minus 2 by 3 means 3x is minus 2 means it's a 0. If x is between minus 2 by 3 and minus 2, this then 3x will be smaller than minus 2. So this term will be negative. Right, so both these cases we'll write. In this case, let's say it's minus 1 by 3, then 3x is minus 1, minus 1 plus 2 is 1, which is positive, so this is positive. So minus 2x, so this will just come out as it is. So we have minus 2x plus x, that is minus x and minus 3x. So minus 4x, and we have 2 and minus 2, which is just 0. Right, so minus 4x in this region. This is also done. Then between this, you have to multiply this by minus 1. Right, or you can just, so this will be plus 2 plus 3x then. Right, so now you'll have minus 2x plus x minus x plus 3x, that is 2x and plus 4. So in this region it is 2x plus 4. Then again you have two branches here, x greater than 2 and 0 less than x less than 2. For x greater than 2 this is negative, for between 0 and 2 this is positive. So we'll just have minus 2 minus x, that is minus 2 plus x. So we'll have 4x, that's it. And here we multiply it by minus 1, or rather just take it as a positive. So 2x plus 4. Right, so this is our function. 2x plus 4, 4x, 2x plus 4, minus 4x, and minus 2x minus 4. So now we can just draw the graph, and I'll just draw the graph here. So this is 0, this is 2, minus 2 by 3, this is minus 2. Right. Greater than 2, it is 2x plus 4. Right, so it is something like this. Between 0 and 2, it is 4x, so it is something like this. Then it is minus 4x, between minus 2 and 3 is 0, so it is something like this. Then 2x plus 4 here, which is the same function as this pulled back, so something like this, and minus 2x minus 4, which is something like this. So this is the graph of this function. And now we can calculate whatever needs to be calculated. Local maximum or local minimum at minus 2, minus 2 by 3, and 0. So the answer to this would be A and B, minus 2 and minus 2 by 3. So the answer is A and B. Quite a lengthy question and easy to make mistakes in this question of a minus sign, but essentially a simple question. The concept was not that hard. 43. W is equal to root 3 plus iota by 2, which can be written as e to the power iota. Cos theta is root 3 by 2, so theta is pi by 6. Right, this is W. And P is equal to W to the power n. Right. So this is r iota to the power pi by 6. That is this, where the angle is pi by 6. Since the magnitude is 1, if you square it, the magnitude will stay the same. The angle will be multiplied by 2. Right, so then it will be pi by 3. If you cube it, this is, so omega square is r iota to the power, sorry, what am I writing? E to the power iota to the power pi by 6. E to the power iota to the power 2 pi by 6. Omega cube e to the power iota to the power 3 pi by 6. Which is this straight line. Then you'll have this term, you'll have this term, basically divided by 60 degrees each. And once you get n is equal to 12, right, n is equal to 12 will be 12 pi by 6 or 2 pi, e to the power iota 2 pi, which will again just be 1. So you'll come back to the original value. So there'll be 12 terms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 terms within this set. After that, it just keeps on repeating. This is the set P, which has 12 terms. Then you have the set H1, in which the real part of Z is greater than 1 by 2. Right. So for this, the real part of Z is root 3 by 2. For this, the real part of Z is 1 by 2. Right, and we want it to be greater than 1 by 2. So these two don't count. So these three are inside, right? This is 30 degrees, 30 degrees. For these three, real part of Z is greater than half. Similarly, only for these three, which belong in H2, real part of Z is less than minus 1 by 2. So Z1 is the member of these three. So Z1 is either e to the power iota pi by 6, or e to the power iota 11 pi by 6, or e to the power iota 2 pi by 6. These three. And Z2 is either e to the power iota 5 pi by 6, or e to the power iota 6 pi by 6, or e to the power iota 7 pi by 6, which are these three. And we need the angles between one and the other. So if we take, let's just take Z1 first. The angle this makes with these three are, this is 2 pi by 3, 2 pi by 3, 5 pi by 6 and pi. The angle the second one makes with these is 5 pi by 6, pi, 7 pi by 6. And the angle which the third one makes with these three is pi, 7 pi by 6, 8 pi by 6, or 4 pi by 3. Now we just look at the options. Pi by 2 is not one of the options, pi by 6 is not one of the options, but 2 pi by 3 and 5 pi by 6 are. So the answer would be C and D. Right, we are just talking about these three make up Z1, these three make up Z2. In the next question, we are given 3 to the power x is equal to 4 to the power x minus 1. What do you do in these questions? The first step, take the log. X ln 3 is equal to x minus 1 ln 4, which means that x times ln 4 minus ln 3 is equal to ln 4, which means x is equal to ln 4 by ln 4 minus ln 3. And after this, you know the properties. Ln of a by b is equal to ln a by ln a minus ln b, and ln a by ln b is equal to ln of a to the base b. These properties you already know for log, right? So now you just look at the options. Option 1 is just divide this by 3. So this will be log 4 to the base 3 by log 4 to the base 3 minus 1. And you write log 4 to the base 3 as 2 log 2 to the base 3. So A is true. What about B? B is also true. You just write this as 2 log 2, 2 log 2 and divide by log 2 everywhere. So B is true. C is also true. Divide by log 4. This will be 1 by 1 minus ln of 3 to the base 4. True. Fourth is not true. D is not true. You cannot simplify it any way to get D. So the answer is A, B, and C. The next question is just a straightforward application of the formulas. You have two lines which are written in the form of x is equal to 5 can basically be written as x minus 5 is equal to 0. Right, that's how we treat that line. So L1 is x minus 5 by 0 is equal to y by 3 minus alpha is equal to z by minus 2. L2 is equal to x minus alpha by 0 is equal to y by minus 1 is equal to z by 2 minus alpha. These are two lines. We need to know if they are coplanar. Well, there's a standard formula to know if they are coplanar, and that is if the determinant of, after you write it in this form, x2 minus x1, y2 minus y1, z2 minus z1, L1 m1 n1, L2 m2 n2 is 0. If this is 0, then they are coplanar. So what is x1 and x2? X1 is minus 5, x2 is minus alpha, right? So this gives us a determinant of 5 minus alpha. Then you have 0, 0, you have 0 here as well, which makes the determinant very simple. Now here what do you have? L and M. L, M and N. This is L, M, N. So 3 minus alpha, minus 2. Minus 1, 2 minus alpha. Which means 5 minus alpha times 3 minus alpha into 2 minus alpha minus 2 is equal to 0. So either alpha is equal to 5 or, which is not one of the options, this term is 0, which means 3 into 2 is 6 minus 5 alpha plus alpha squared minus 2 is 0, which means alpha squared minus 5 alpha plus 4 is 0, which means alpha minus 1 into alpha minus 4 is 0, which means alpha is equal to 1 or 4. So the answer to this problem is A and D. Straightforward application of the formula in that one. 46 now. You have a triangle PQR with P as the largest angle and there being an inner circle, and the lengths of Pn, the lengths of Pn, QL and Rm are in the ratios of even integers. So they are like, if this is 2k, this is 2k plus 2, and this is 2k plus 4. So obviously this is 2k plus 4, this is 2k, and this is 2k plus 2. Right, because these two sides are equal since this is the in-center. And what are the possible lengths of the side? So there's only one equation given really, cos p is equal to 1 by 3. Right, so what is cos p? We know, we'll just apply the cosine rule here. So c square, which is 4k plus 6 whole squared, is equal to a squared plus b squared 4k plus 2 whole squared plus 4k plus 4 whole squared minus 2ab 2 4k plus 2 4k plus 4 cos theta, which is 1 by 3. So minus 2 by 3. Right, we'll just take 3 to the other side, which will give us 3 times 4k plus 6 whole squared is equal to 3 times 4k plus 2 whole squared plus 4k plus 4 whole squared minus 2 times 4k, this is plus 2, plus 2 4k plus 4. So the first thing we can just do for the sake of simplification is just cancel out all the 4s, that is 2 squares. So we get 3 times 2k plus 3 whole squared is equal to 3 times 2k plus 1 whole squared plus, this is also 3, 3 times 2k plus 2 whole squared minus 2 times 2k plus 1, 2k plus 2. Now there's nothing left to do but solve. So this is 4k square into 3, 12k square. This is 2 into 2, 4 into 3 is 12 into 3 is 36. Plus 27 is equal to 12k square plus 12k plus 3 plus 12k squared plus 24k plus 12 minus 2 times 4k square plus 6k plus 2. So minus 8 minus 8k square minus 12k minus 4, which means 12k square cancel. So we are left with 4k square, 2k, 12k, 24k is 36k minus 12k is 24k minus 36k is minus 12k, and 3 and 12 is 15 minus 4 is 11 minus 27 is minus 16, 0, or k square minus 3k minus 4 is equal to 0, k square minus 4k plus k minus 4 is equal to 0, or k is equal to minus 1 or 4. Minus 1 does not give us proper values because the side will be minus 2 then, but 4 does give us proper values. So for 4 the side will be k is equal to 4, implies 4k is 16, so 16 plus 6, 22, 20 and 18. So the answer is B and D. Now the 47th question is one of the more difficult questions in this paper, and one of the things you have to do is convert a sum into an integral in this problem. So let's try to do this. We'll apply the limit is equal to 1 by 60 later on. Right now we are just concerned with the function. 1 to the power a plus 2 to the power a plus dot 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 plus n to the power a by n plus 1 to the power a minus 1 times na plus 1 plus na plus 2 plus dot 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 na plus n. So first what we can do is we can take n to the power a common from the numerator. 1 by n whole to the power a plus 2 by n whole to the power a plus 3 by n whole to the power a plus dot 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 plus n by n whole to the power a divided by, this becomes n plus 1 to the power a minus 1, and now na is added n times, there are n terms, so from that we get n square a plus, and then the sum of the first n natural numbers, n into n plus 1 by 2. This is what we get. Right, now we can write this a little bit more simply as n to the power a by n plus 1 to the power a minus 1 times n. Let's just take this to be n to the power a minus 1, remove one n, na plus n plus 1 by 2. This multiplied by something else, this is just this term multiplied by this, which is sum of r is equal to 1 to n 1 by n r by n whole to the power a, right, and the limit is n goes to infinity, right, for this thing. So now we'll just look at this term in a little bit more detail, and we'll just add the rest of the terms later on, right. Summation r is equal to 1 to n r to the power na limit n goes to infinity. So I'll rub everything above that, and we'll just try to calculate this sum first, right, because that's basically what the whole question boils down to, even though the simplification after and before that is also not trivial. But now, so we are looking at limit n goes to infinity, summation r is equal to 1 to n r by n whole to the power a. If we draw a graph of this, it is 1 by n whole to the power a, right. So let's say this is x, and this is the graph of x to the power a, which is y, right. 1 by n, 2 by n, 3 by n, dot dot dot, till n by n, which is basically between 0 and 1, right. Now 1 by n to the power a, let's say, has this value, right. Then what we can do is we can multiply it by 1 by n, and we can take n outside, n times this, right. Now what is 1 by n to the power a, which is this side, multiplied by 1 by n, area of this block? What is 2 by n to the power a multiplied by 1 by n, area of this block? 3 by n to the power a, area of this block. So that is one thing. The other thing is, as n goes to infinity, these terms go to 0. So it becomes closer and closer together. So basically it is sort of like the integral of x to the power a. That is the whole thing here, right. This, because n is going to infinity, these terms are going to 0, which means the sum can be replaced by an integral. Remember, what is an integral? Integral is f of x dx, in which dx is very, very small and the number of terms are infinity. That's why it's replaced by an integral. Dx is like 1 by n, very, very small, and the number of terms are infinity. So this is the sum of an infinite number of infinitesimally small terms. You add a finite number of finite terms, that's summation. You add an infinite number of very small terms, that's an integral. What will be the limits? 1 by n is basically 0 and n by n is basically 1. Right. So this can be written as n times this thing. Right. And this thing is basically integral of 0 to 1 x to the power a dx. right? So now this is what we put here. So instead of this, now what is the value of this? X to the power a has an integral x to the power a plus 1 by a plus 1. You take limits from 1 to 0, you just get 1 by a plus 1. 0 to 1. 0 gives 0, 1 gives 1 by a plus 1. So this is n by a plus 1. So this can be replaced by n by a plus 1. So the final thing that is left is n to the power a by n plus 1 to the power a minus 1 n times a plus half plus half. Right, this is what is left. Now this just gives us n by n plus 1 to the power a minus 1 is 1, n to the power a by this is again 1. So all that is left to us is 1 by a plus half, and obviously the 1 by a plus 1 from here comes as well. This n made this 1, so 1 by a plus 1. This is given to us to be 1 by 60. We can write this as 2a plus 1, and this is 2, which means a plus 1 times 2a plus 1 is equal to 120. Now this is a quadratic equation. 2a square plus 3a plus 1 is equal to 120. So 2a square plus 3a minus 119 is equal to 0. Now you can do it by splitting the middle term, but when there's not a lot of time and you can't think of how to split it, just as I wasn't able to, there's nothing wrong in using the standard minus b plus minus formula. And if you can do it by splitting the middle term, then that would just give you a perfect square, right? So I'll just do that. A is equal to minus 3 plus minus root of 9 plus 8 into 119 by 4, and this whole thing comes out to be the square of 31. So we get minus 3 plus minus 31 by 4, which means minus 34 by 4 or minus 17 by 2, and 31 minus 3 by 4 or 7. So 7 or 17 by 2, which gives me B and D. So this was one of the more difficult questions. Not only was the main thing converting a sum to an integral, which is itself quite difficult, but then there's a lot of simplification involved as well. Right. So this gives me option B and option D. Let's move on to the next question, 48. You are given a circle which touches the x-axis at x is equal to 3. Now then the one thing we can be sure is that this is perpendicular to the tangent, or this is the radial direction, which means the radius has to lie on this line, which means the x coordinate of the radius has to be 3. So the equation will be x minus 3 whole squared plus 2 more parameters y minus alpha whole squared is equal to r squared. Right, so this is the standard equation, and now we are given that the intercept is of length 2 root 7 on the y-axis. On the y-axis x is equal to 0, so we get y minus alpha whole squared is equal to r squared minus 9, or y minus alpha is equal to root of r squared minus 9 plus minus, or y is equal to alpha plus minus root of r square minus 9. Right, so y is either alpha plus root of r square minus 9 or alpha minus root of r square minus 9, these two terms. So what is the difference between them? That is this length. The difference is 2 root of r squared minus 9. Strangely, it does not depend on alpha. This is given to us to be 2 root 7, which means r square minus 9 is equal to 7, which means that r is equal to plus minus 4. R is the radius, r is equal to minus 4 doesn't make sense, so we'll take r is equal to 4, which means alpha is well, we can't really tell what alpha is because we don't have any equation for alpha, right? Y is equal to alpha plus minus this. So we don't exactly know what alpha is, but that's why it said this it circles R. So let's just simplify this then. This becomes x squared plus y squared minus 6x minus 2 alpha y plus 9 plus alpha squared minus 16. So alpha squared minus 7. This is equal to 0. So whichever options are of this form will be the answer. So it has to be minus 6x. So that is given in all the forms. Then you have plus minus 8a or plus minus 8y or plus minus 7y. Right. And this is alpha squared minus 7. So let's just look at all options individually. Let's look at option A. Option A says plus 8y, which is minus 2 alpha. So alpha is equal to minus 4, which means alpha square minus 7 is 9. And it says plus 9 is equal to 0. So A is true. A can be possible. B says alpha is equal to minus 3 by 2. Well, if alpha is minus 3 by 2, then alpha square minus 7 is 9 by 4 minus 7. Which is not equal to 9, but this term is given to us as 9. So B is not possible. C similarly is possible because alpha will be 4 and alpha square minus 7 is still 9, and D is not possible. So the answer will be A and C. So we can't explicitly calculate the value of alpha, but then based on whatever options are given, we can actually find out the final answer. Let's move on to the next set of questions, 49 and 50. So let's do 49 first. So in the 49th question, we are given f of 0 is equal to f of 1 is equal to 0 and f double dash of x minus 2 f dash of x plus f of x greater than equal to e to the power x. Right. So from that, what can we tell? Well, let's look at the term e to the power x, e to the power minus x fx. Let's say this is gx. Then what is dg by dx? It is e to the power minus x f dash minus e to the power minus x f. What is d2g by dx squared? It is e to the power minus x f double dash minus e to the power minus x f dash minus e to the power minus x f dash plus e to the power minus x f, which is equal to e to the power minus x f double dash minus 2 e to the power minus x f dash plus e to the power minus x f. Now if this is greater than e to the power x, then multiply both sides by e to the power minus x. You will see that this is this term, which is greater than 1. So what we are given is d2g by dx square is greater than equal to 1. Right, so d2g by dx square is greater than equal to 1, which means that this function g, which is e to the power minus x fx, is concave up. Right, this is a concave up function, this is a concave down function. And if this is concave up, then fx will also be concave up within the range 0 to 1, because within the range 0 to 1, e to the power minus x behaves quite normally between 1 and 1 by e. We know that for fx, f of 0 is equal to f of 1, which is 0, and it is concave upwards. So the only possible way is that it is something like this, which means that between 0 and 1, it has to be negative. If between 0 and 1, fx is negative, that means option D is correct. I repeat, this tells us that it is concave upwards. If a function is concave upwards and 0 at 2 points, then between those 2 points it has to be negative. Right, if it is always concave upwards, and fx is always concave upwards, that is what it is given to us. Right, so let's look at the next one, which is based on the same paragraph, 50. We are given e to the power minus x f of x is minimum at x is equal to minus 4. So let's take this function to be gx, which we just did. G dash x is equal to e to the power minus x f dash x minus e to the power minus x f of x, which is equal to e to the power minus x f dash x minus f of x. Right, and this is equal to 0 at x is equal to 1 by 4. Going by what we already know previously, fx is 0 at 0 and 1. Therefore, it is something like this. Therefore, it is something like this. And if gx has a derivative which is 0 at x is equal to 1 by 4, that means e to the power minus x is between 0 and 1, right? So that doesn't matter. That means there are two terms like this. This is the term where it is 0. That means before that, between 0 and 1 by 4, it has to be negative, and between 1 by 4 and 1, it has to be positive, this term. That means f dash has to be less than f between 0 and 1 by 4, and f dash has to be greater than f between 1 by 4 and 1. Right, so the only correct option is C. So the answer to this is C. Let's move on to the next question, 51. So we are given a standard parabola y squared is equal to 4ax with 2 points making a focal chord P and Q. We know that in the parametric form we can represent a point as at square comma 2at. So we'll say this is at1 square comma 2at1, and this is at2 squared comma 2at2. We also know the tangent from a point represented by the parameter t is yt is equal to x plus at squared. So for these two equations, it would be yt1 equals x plus at1 squared and yt2 equals x plus at2 squared. We can solve these two. First we subtract them. Y times t1 minus t2 is equal to a times t1 squared minus t2 squared, which gives us y is equal to a times t1 plus t2. Substitute this in the first equation. We get a t1 squared plus a t1 t2 is equal to x plus a t1 squared, which means that x is equal to a t1 t2. Y is a t1 plus t2, x is equal to a t1 t2. Right. Now we know another thing about this line, this point, which is that it lies on y is equal to 2x plus a. That means a times t1 plus t2 is equal to 2a t1 t2, that is 2x plus a. And one thing we already know is that if 2 points on a parabola are ends of a focal chord, then t1 t2 equals minus 1, and we can use that. So this is equal to minus a, which means t1 plus t2 is equal to minus 1 as well. What about t1 minus t2? We'll need that. That is equal to root of t1 plus t2 whole squared minus 4 t1 t2, which is equal to root of minus 1 whole squared plus 4, which is root 5. So t1 minus t2 is equal to root 5. Right? This is the first question, first part. Now we need to find out the length of the chord PQ. Right, so I'll just rub this part for a minute. Because all that was important in that was these three relations. Now the length of the chord PQ will be root of this minus this whole square plus this minus this whole square. So a t1 squared minus a t2 squared whole squared plus 2a t1 minus 2a t2 whole squared. That is equal to root of a squared times t1 squared minus t2 squared is t1 minus t2 into t1 plus t2, which is minus root 5. You square that, you get 5. Plus 2a comes out common, 4a square times t1 minus t2 whole square, that is 5, which means root of 25a square, which is 5a because it is given to us a is positive. So the answer to 51 is B. Right. 52 is based on the same parabola. We are given that this total angle subtended by PQ is theta. Right. Let's say this is theta 1 and let's say this is theta 2. Right. What is tan theta 1? It is equal to y by x. Right. 2at1 by at1 squared, which is 2 by t1. Tan theta 2 is equal to 2 by t2. Right. What we need is tan theta 1 plus theta 2. Right. So these two mean tan theta 1 plus theta 2. We already know what that is. Tan theta 1 plus tan theta 2 by 1 minus tan theta 1 tan theta 2. But there is a slight catch here which might confuse a few students. So look closely for a second. We know that t1 is positive, x is positive in both cases, and t1 is positive because y of p is positive, and t2 is negative because y of p is negative, y of q is negative. Right, but theta 1 and theta 2 are both in the first quadrant whose tan will be positive. So tan theta 2 actually is minus 2 by t2. Another way to explain this is we are actually measuring it in this direction. Right, we always go from the positive x-axis. To go in this direction, theta 2 itself will be negative. So if we want to take theta 2 as the magnitude of it, then we need to take this. Right, so this is important. Just pay attention to this. Remember that t2 is negative and theta 2 is between 0 and 90. So there has to be a minus sign here, right? Another way you might see it is, actually what is 2 by t2? Y by x. 2 by t2 is this total angle. 2 by t2 is 360 minus theta 2. Right, from that you get the same thing. So this is important. A lot of students will take this to be 2 by t2 and they'll get the wrong answer. Right, so make sure you know about this. This is an important point. Tan theta 1 plus tan theta 2, simply tan theta 1 plus tan theta 2 by 1 minus tan theta 1 tan theta 2, or 2 by t1 minus 2 by t2 by 1 plus 4 by t1 t2, which is equal to 2 times t2 minus t1 by t1 t2 plus 4 is equal to minus 2 by 2 times t2 minus t1 is minus root 5. So minus 2 root 5 by t1 t2 is minus 1 plus 4 is 3. So minus 2 root 5 by 3 is the answer, which means D. So make sure you understand this point. This is the most important point here in this question. Let's look at the next set of questions. 53. We are given three sets. S1, which is a set Z such that mod Z is less than 4. S3, which is a set Z such that real part of Z is greater than 0. And S2, which we'll simplify further, which is a set Z such that the imaginary part of Z minus 1 plus root 3 iota by 1 minus root 3 iota is greater than 0. So let's simplify this number first and say z is equal to x plus iota y. So we get x minus 1 plus iota times y plus root 3 by 1 minus root 3i. Right, z minus 1 plus root 3i. We know what we do here. We multiply it by 1 plus root 3i by 1 plus root 3i. From that we get x minus 1 plus iota times y plus root 3 plus root 3i times x minus 1 minus root 3 times y plus root 3 by 4. Now we'll just look at the imaginary part of this, which needs to be greater than 0. That means I times, or I will just remove and we'll just take the imaginary part, y plus root 3 plus root 3x minus root 3 by 4 should be greater than 0. This is of no significance by 4 and root 3 cancel. That means root 3x plus y should be greater than 0. That is S2. Root 3x plus y is greater than 0. Right. So let's rewrite these three. S1 says mod z is less than 4. So if this is our complex plane, this would be set S1 2, 2, 2, minus 2, minus 2. S3 was real part of z greater than 0. So this is S1. All of this is S2, real part of z greater than 0. What about S3, real part of z greater than 0? What about S2? It says that root 3x plus y greater than 0. So if root 3x plus y was equal to 0, y was minus root 3x, and the line would be something like this, where y would be minus root 3x, so this would be 60 degree and this would be 60 degree. So this is the line root 3x plus y greater equal to 0. Root 3x plus y greater than 0 is on the upper side of this line. Right, so all of this is root 3x plus y greater than 0. And we can see the part where these three intersect is this region, this sector. This is S, which is the intersection of the three. What is the area of S? This angle is 90 plus 60, that is 150. So 150 by 360 times pi r square. That means pi into 4. Right, 15 by 36 will be 5 by 12. This is 3, so 5 pi by 3. Hang on. Sorry, my mistake. These are 4, right? Mod z is 4, not root of mod z. Minus 4. Minus 4, so this should be 4 squared. So into 4, which is 20 pi by 3. So the final answer is 20 pi by 3, which is B. Let's look at 54, which is based on the same paragraph. You have the minimum value, or you want the minimum value of 1 minus 3 iota minus z, which can be written as the mod of this, which you want the minimum value, can be written as the mod of z minus 1 minus 3 iota. Which means the distance between z and 1 minus 3 iota. So x is 1, y is minus 3. What is this line? If x is 1, y is minus root 3. So this is below this, somewhere here. Minus x is 1, y is minus 3. Right. Minimum distance between this and this sector will be this distance. But if you think about it, this distance is just the perpendicular from this point to this line. We already know what the what the formula for perpendicular is. Just put this here and divide by root a square plus b square. So we'll have root 3 minus 3 divided by root of 1 square plus root 3 whole square, or 2, which is equal to root 3 times 1 minus root 3 by 2. But we want the modulus, so we can just put a minus sign. So it will be 3 minus root 3 by 2, which means the answer will be C. 3 minus root 3 by 2. Right? We basically did this whole question graphically, which shows you how the mapping of complex numbers on the xy plane is very useful. Let's look at 55. You have 3 boxes. This is the first box, the second box, third box. The first has 1 white, 3 red and 2 black. 1 white, 3 red and 2 black. The other has 2 white, 3 red and 4 black. And 3 white, 4 red and 5 black. One ball is drawn from each of the 3 boxes. The probability that the ball is of the same color. So it can either be all 3 white or all 3 red or all 3 blue. So we'll add those 3 probabilities and add them up because they're independent events. So the probability that all 3 will be white will be, this has a total of 6 entries, this has a total of 9 entries, and this has a total of 12 entries. Right. So there is only one white, so 1 by 6 are the chances this has a white ball, into 2 by 9 are the chances this gives a white ball, into 3 by 12 the chances this gives a white ball. This is the chance that all 3 will be white, plus the chance all 3 will be red, that will be 3 by 6 into 3 by 9 into 4 by 12, plus the chance that all 3 will be black, 2 by 6 into 4 by 9 into 5 by 12. Now you just add them up. So let's just say 6, 9 and 12 is the denominator here. 6, 9, 12 multiplied by 9 multiplied by 12. The numerator is 3 and 2 is 6, plus 9 and 4 is 36, plus 40, which is equal to 40 and 36 is 76, 82. 82 by 6 into 9 into 12, which is 12 into 9 is 108 into 6. 100 into 6 is 600. 8 into 6 is 48, 648. 82 by 648, which means the answer would be A. Let's look at 56, which is based on the same information. 2 balls are drawn from a randomly selected box, and one is white and the other is red. So the probability that these were drawn from box 2. So 2 balls are drawn, one is white, the other is red. First we'll find the probability of this event, and then we'll find out what is the probability that this happened in 1, 2 or 3. Right, and the box is randomly selected. So there is a third probability for each box. Right. So if we take 2 from the first box, the chances are one will be black and the other will be red is, the chances are one will be black will be 1 by 6, and actually there's a better way of doing it. The total way of selecting 2 balls is 6C2. Right. Now there is 1 white ball and 3 red balls. So that is the total number of combinations of 1 white and 3 red balls. So this is equal to 3 divided by 6C2 is 6 into 5 by 2. That is 1 by 5. This is box 1. That means if you take 2 balls from the first box, the probability will be 1 by 5 that one is white, the other is red. Similarly for B2, if you pull 2 balls, 2 white and 3 red divided by 9C2, which is 2 into 3 into 2 by 9 into 8, 2, 3, which is 1 by 6. And for B3, the same thing is 3 into 4 by 12 C2, or 3 into 4 into 2 by 12 into 11, which is 2 by 11. So these are the three probabilities. That means if you take a box at random, there is a 1/5 chance that if it has one white ball, if you take two balls at random from the first box, there is a 1 in 5 chance one is white, the other is red. There is a 1 in 6 chance in the same case for the second box, and there is a 2 in 11 chance in the same case for the third box. Right. Now what is the probability that this box is selected? 1 by 3. What is the probability that this box is selected? 1 by 3. This is 1 by 3. Because it's randomly selected. Right. So what is the total probability that you will select a box from B2 and you will select balls from B2 and those balls will be one white and one red? 1 by 3 into 1 by 6. Right. What is the total probability that if you select two balls from one of the three boxes, it will be one white and one red? The sum of these three. 1 by 3 into 1 by 5 plus 1 by 3 into 1 by 6 plus 1 by 3 into 1 by 11. Actually, to be honest, I could have just taken this divided by the total sum, which is always true if each of these three has an equal probability of being selected, because we can see that 1 by 3 actually cancels out. Right. Let's say, for example, to make this a little bit clear, let's say you do an event in two locations, A or B. If you do the event in location A, there's a 10% chance that something might happen. If you do the same thing in location B, then there's a 50% chance that the same thing might happen. Then it's 5 times as likely to happen in B than it is to happen in A. So we can say that if it did happen, 1 by 6 probability it happened in A and 5 by 6 probability that it happened in B. Right, because we just selected one randomly, and 50% of the time this did that, which is 5 times as much as this. So 10%, 50% tells us B is 5 times as likely as A to do the thing. Then you just calculate the probability. So this is the answer, and if you calculate it and simplify it, it will come down to be 55 by 181. So the answer to this problem is D. Let's move on to match the following now, starting with 57. These are just 4 independent options, so we'll do each separately. P says that volume of the parallelepiped determined by the vectors A, B and C is 2. That means A dot B cross C is equal to 2, or mod of this is equal to 2. What is the volume of the parallelepiped determined by 2A cross B, 3B cross C and 5C cross A? Right. So we'll just take the triple product of that. So what we'll get is 2 times A cross B. This is the first vector. Dot product with the second and the third. D 3 times B cross C. Cross product with C cross A. This is equal to 6 times A cross B dot. Now we can just use the, we can use the rule which we know. A cross B cross C is equal to B times A dot C minus C times A dot B. And we have, since 4 cross terms, we can take this as the first term, alpha. This is beta, this is gamma. Right. So it will be C times the dot product, B times, which is C here, the dot product of these two terms. That is A dot B cross C minus A times the dot product of these two terms, which is 0, because B cross C is perpendicular to C. So what we get is Now this is just a scalar, it comes outside. So 6 times A dot B cross C multiplied by A dot B cross A cross B dot C. But we see this is just C dot A cross B, which is the same thing, 2 again. So this is equal to 2, this is equal to 2, this is 6. So P comes out to be 24, which is the option 3. Similarly, let's do Q. We are given A dot B cross C is 5 and we need 3A plus B dot B plus C cross 2 times C plus A, which is 6 times A plus B dot 2 times B, this is B cross C plus B cross A plus C cross C is 0 and C cross A. Now A plus B dot this, right? So that means A dot this plus B dot this. So 6 times A dot, what is A dotted with? This is B cross C and A dot B cross A is 0 and A dot C cross A is 0. Similarly, plus B times dotted with B cross C is 0 and B cross A is 0. So B dot C cross A, which is in the same order A, B, C. So this is 5 and this is 5. So the sum is 10 multiplied by 6 is 60. So Q goes to 4. So P goes to C, 3, Q goes to 4, which means the answer obviously is C. But let's do the other two options as well, R and S. The answer is option C because that's the only option in which P goes to 3 and C goes to 4. P goes to 3 and Q goes to 4. Now the area of the triangle with adjacent sides determined by A and B is 20. That means half of A cross B is 20. That means mod of A cross B is 40 because area of the triangle is half of A cross B. Area of triangle determined by 2A plus 3B and A minus B is half of 2A plus 3B cross A minus B, and A cross A and B cross B will be 0. So this is half of minus A cross B plus 3 times B cross A. Or this is minus of A cross B is B cross A. So 4 times B cross A by 2 is 2 times this is minus 2 times A cross B because this is a 2. So this will be 2 times B cross A. So total is 5 by 2 times B cross A. Mod of B cross A is 40. So 5 by 2 into 40 is 100. So consistent with C, the answer is 1. And for S, area of a parallelogram determined by A and B is 30. So mod A cross B is equal to 30. And we need it by A plus B and A. So A plus B cross A, which is the same as B cross A because A cross A is 0, which is also 30, which is 2. So the answer again is consistent with C. Actually, an interesting thing here is R and S were much shorter than P and Q, and if you just read the whole question first, you could see that if you just solve R and S, you'll get to know the answer, which would have been C. But personally, I always, if I have enough time, like to check all 4 problems just in case I made a mistake somewhere. And you should try to do that too whenever you have extra time. Let's go to 58. We are given two lines L1 and L2. L1 is x minus 1 by 2 is equal to y by minus 1 is equal to z plus 3 by 1. If we take this equal to k, then I can write the point as x is equal to 2k plus 1 comma minus k comma k minus 3. The second line is x minus 4 by 1 is equal to y plus 3 by 1 is equal to z plus 3 by 2 is equal to L, let's say, which means that the points are L plus 4, L minus 3, 2L minus 3. So these are the 2 points. Now we are given that the plane AX plus BY plus CZ plus D is equal to 0 is perpendicular to the 2 planes which are given as 7x plus y plus 2z is equal to 3 and 3x plus 5y minus 6z is equal to 4. Now we know when 2 planes are perpendicular what happens. The dot product of their direction cosines is 0. Right, or you know the condition as a1 a2 plus b1 b2 plus c1 c2 is 0. Right, from that what we get is 2 equations, 7a plus b plus 2c is equal to 0 and 3a plus 5b minus 6c is equal to 0. Now we can solve these two. An easy way is to multiply the first by 3 and add it, then c will cancel. So then we'll get, if we multiply the first by 3, 21 and 3 is 24a plus 8b is equal to 0, or b is equal to minus 3a. Put it in the first one, 7a minus 3a is 4a plus 2c is equal to 0, so c is equal to minus 2a. So we get two nice equations from here, b is equal to minus 3a and c is equal to minus 2a. Finally what we are given is that this plane passes through the point of intersection of L1 and L2. So now our goal is to find the point of intersection of L1 and L2. I'll just remove this stuff because we've already used this to find out what we needed. That means the intersection of L1 and L2 lies on the plane AX plus BY plus CX is equal to D. CZ is equal to D. So the intersection will give 2k plus 1 is equal to L plus 4, minus k is equal to L minus 3, k minus 3 is equal to 2L minus 3. We can just add the second and third and we'll get minus 3 is equal to 3L minus 3, or from that we get 3L minus 6, sorry. So we get L is equal to 1. From this we get k is equal to 2 and satisfies all three. 4 plus 1 is 5 is 1 plus 4. Minus 2 is 1 minus 3. 2 minus 3 is 2 minus 3. Yeah, so which gives us the point 2k plus 1 is 4, comma minus 2, comma minus 1. Sorry, this is 5. 5, comma minus 2, comma minus 1, 2k plus 1. This point passes through ax plus by plus cz plus d is equal to 0. That means 5x, 5a minus 2b minus z is equal to d. Right. And b and c are minus 3a and minus 2a. So we get 5a minus 2 times minus 3 is plus 6a. This should be minus 3. Minus of minus 2 is plus 2a is equal to d, and from that we get d is equal to 13a. And that's it. We can't determine the fourth one because the any equation can be multiplied by 4 on both sides and it will give us the same thing. So minus 3, minus 2, 13 and 1. So we can see from the options that if a is 1, b is minus 3, c is minus 2 and d is 13, which gives us the first option. P goes to 3, then Q goes to 2, R goes to 4 and S goes to 1. 3, 2, 4, 1, which is option A. So the answer to problem 58 is option A. Let's move on to the next question, 59. Let's start with option P. We are given y square, 1 by y square, the root of a big thing which is 1 by y square times. I'll just write the terms directly from here. Something squared plus y to the power 4, and this is a fraction, and the first term is cos of tan inverse y. If tan theta is y, then the perpendicular by base is y, so cos theta is 1 by root of 1 plus y squared. Then you have y times sine of tan inverse y, which would be y by root of 1 plus y squared. And here cot of sine inverse y, if sine theta is y, then cot theta will be root of 1 minus y squared by y, plus tan of sine inverse y, that will be y by root of 1 minus y squared. Right, so this is the first step, and I'm sure you know how to do this. And then after this, you can see that this is equal to 1 by y squared plus y to the power 4 to the power 1 by 2 of this term. And this term we can just start simplifying. The numerator is 1 plus y squared, the denominator is root 1 plus y squared. When they cancel, they give root 1 plus y squared. And here it's root of 1 minus y squared whole square, that is 1 minus y squared plus y squared, so it's 1. But then the denominator here is y root of 1 minus y squared. So you have another y, and you have root of 1 minus y squared, which multiplied by 1 plus y squared gives 1 minus y to the power 4. Y cancels with y square, 1 minus y to the power 4 root squared becomes 1 minus y to the power 4 plus, I'll just write it down. Let me just write it down from here in case you don't get it. Right, so this is 1 plus y square by root of 1 plus y squared divided by y root of 1 minus y squared root of 1 minus y squared whole squared plus y squared. So this is easy. This is root 1 minus y squared plus y squared, which is 1. So this term is just 1. This goes up, and what it becomes is these cancel and become root of 1 plus y squared. So this whole terms becomes root of 1 plus y squared y root of 1 minus y squared, which is y root of 1 minus y to the power 4. This is the term in the bracket. When you square it, you get y square times 1 minus y to the power 4. Y square cancels with y square. You have 1 minus y to the power 4 plus y to the power 4 to the power 1 by 2, which is 1 to the power 1 by 2, which is 1. So p goes to 1. P goes to the value 1, which is option 4. Right. Now similarly, let's look at q. We are given cos x plus cos y plus cos z is equal to 0. So this is equal to minus cos z. Sin x plus sin y plus sin z is equal to 0. So this is equal to minus sin z. And now you can square and add them, and the LHS will be cos square x plus cos square y plus sin square x plus sin square y plus 2 cos x cos y plus 2 sin x sin y. So 2 plus 2 cos x cos y plus 2 sin x sin y is equal to 1, which means cos x cos y plus sin x sin y is cos of x minus y. Right, so 2 cos of x minus y is equal to minus 1, which means cos of x minus y is equal to minus 1 by 2. But this is equal to 2 cos squared x minus y by 2 minus 1, which means 2 cos squared x minus y by 2 is equal to 1 by 2. Take this here, cos squared of this is 1 by 4, which means cos of x minus y by 2 is plus minus 1 by 2, and 1 by 2 is an option, so Q goes to option 3. So P goes to option 4, Q goes to option 3. Right. Now we need to look at R and S. But there's a quick shortcut. We can see that R asks the possible value of sec x. Right. Sec x is always bigger than 1 or smaller than minus 1. And the only option satisfying that is option 2. So R should go to option 2, which means the answer is option B. But we'll do R and S anyway, just to make sure. So R says that cos of pi by 4 minus x cos 2x plus sin x sin 2x sec x is equal to cos x sin 2x sec x plus cos of pi by 4 plus x cos 2x. So we can open up these two terms knowing the formula of cos a minus b and cos a plus b. So it gives us cos pi by 4 cos x plus sin pi by 4 sin x cos 2x, and we'll take this to the left side, minus cos pi by 4 cos x minus sin pi by 4 sin x cos 2x, and this is equal to, we take this term to the right side, sin 2x sec x cos x minus sin x. But cos pi by 4 cos x cos 2x cancels, and what we are left with is 2 sin pi by 4 sin x cos 2x. Right, sin pi by 4 is 1 by root 2, so 2 sin by 4 can be written as this by root 2. Now we can take sec x to this side, so sin x cos x, 2 sin x cos x is sin 2x, so this can be written as sin 2x by root 2. Right, this should be root 2 here, sorry, because 2 sin pi by 4 is root 2. Right, take sec x here, and we can get 2 sin x cos x by root 2, right, writing it as 2 by root 2. So we'll get sin 2x cos 2x by root 2 is equal to sin 2x cos x minus sin x. Take both to one side and take sin 2x common. Sin 2x times cos 2x by root 2, which we can write as cos square x minus sin square x by root 2 minus cos x minus sin x is equal to 0, which means sin 2x, cos x minus sin x comes common, and then cos x plus sin x by root 2 minus 1. So if cos x is equal to sin x, then this is 0, which is true when x is equal to pi by 4. Incidentally, when x is pi by 4, 1 by root 2 plus 1 by root 2 is 2 by root 2, and divided by root 2 is 2 by 2, 1 minus 1 is 0. So both these terms are 0 when x is pi by 4, and that is when sec x is equal to root 2, which we knew was going to be, because we already found the answer to be b. Only root 2 is a value greater than 1 or less than minus 1. Finally, let's do s for the sake of completeness. Cot of sine inverse root 1 minus x squared is equal to sine of tan inverse x root 6. What is cot of sine inverse 1 minus x square? The sine of something is root 1 minus x square. Means root 1 minus x square is the perpendicular and 1 is the hypotenuse. Right? Perpendicular by hypotenuse. So that means x is the base. So this is x by root 1 minus x squared is equal to, again, x root 6 is the perpendicular, 1 is the base. So x root 6 by 1 plus 6x squared root. Right, x and x cancels, so we get 1 plus 6x squared is equal to 6 minus x squared. Six minus 6x squared, which means 12x squared is equal to 5, which means x is equal to 5 by root 3, and there's a 2 here as well, half of 5 by root 3. half of root 5 by root 3, sorry, which is option 1, which we knew had to be correct because we already found out that the answer was C. Let's do the final question of this maths paper, question number 60. We are given a line y is equal to mx plus 3 and it meets the x-axis at 0, 3, which we can directly see. So let's draw the figure. This is, let's say, point E, which is 0, 3. Right. The arc of the parabola y square is equal to 16x and y is between 0 and x meets this line at f, which is x0, y0. Right, so let's say the line is something like this and it meets the line, let's say, someplace like here. Sorry. Let's say this is the parabola. So it meets it at the point f, where f is x0, y0. We don't know what it is, yes. And the tangent at f intersects the y-axis at g. So f has a tangent to it which intersects the y-axis as g. And let's just call this point y. So we have x0, y0 and y, 3 unknowns. The slope m of this line, y is equal to mx plus c or mx plus 3, is chosen such that the area of EFG is the maximum. And then we are asked some questions. Right. So let's just try to calculate some relations in between. We know what the area is. If this is y, the area will be half into 3 minus y, half into base, into altitude, which is x0. Right, this is the area. But before that, we can find out a couple of things. This point f is the intersection of this line and the parabola. So y0 squared is equal to 16x0, and also y0 is equal to mx0 plus 9, which means 16x0 is equal to m squared x0 squared plus 18mx0, this is equal to mx plus 3, sorry, 6mx0 plus 9, which means m squared x0 squared plus 6m minus 16 mx0 plus 9 is equal to 0. Now we also know the equation of a tangent. For any point, the equation of a tangent at a parabola is y is equal to, I'll just use m1 because m is already in use, m1x plus a by m. A is 4 in this case. This is the standard tangent, and if this is the equation of this tangent, then if this is y1 is equal to 4 by m1, which means y is equal to 4 by y1x plus y1, and this passes through x0, y0, which means y0 minus y0 is equal to 4x0 by y1 plus y1. Right, and finally we can calculate this value of m1 itself. The slope of the parabola at this point must be the same slope, right? And if y square is equal to 16x, 2y, y dash is equal to 16, implies y dash is equal to 16 by 2y. That means the slope at this point is 16 by 2y0. But we already know what it is. It is 4 by y1, right? So from that we get y0 is equal to 2y1. All of this was done so that we can get x0 and y1 in terms of y0, right? So we have 3 minus, I'll just repeat it now, rub it now. We have 3 minus y1 by 2 times x0. Now y1 we found out was y0 by 2. So this is 3 minus y0 by 2 times, and x naught we know what that is. Y square is equal to 16x, so x is equal to y squared by 16. Right? What is this equal to? 6 minus y naught times y naught squared by 32. This is the area, and the slope is chosen such that this area has a local maximum. So its derivative with respect to y naught must be 0. That means you have 6 minus y naught times 2y naught by 32 plus y naught squared by 32 times minus 1 is equal to 0. So we get 12y naught minus 2y naught squared is equal to 0, which means y naught is equal to 1 y naught will cancel, so 12 minus 2 y naught is 0. Sorry, this is minus 3 y naught square because there's a 2 here, and y naught is not 6, y naught is 4. Y naught is 4 gives us x naught is 1 and y1 is equal to 2. And what is the maximum area? You can just put that in. X naught is 1, y1 is 2. So 3 minus y1 is 1. 1 by 2 is just 1 by 2. And from that you get the answer A, which is, we need to find small m as well. What was small m? Small m is, you get that from y is equal to mx plus 3 was the line. We had the original equation m naught x naught squared plus 6m minus 16 x naught plus 9 is equal to 0, and x naught is 1. So this becomes m naught plus 6m m plus 6m minus 16 plus 9 is equal to 0. 7m minus 7 is 0, or m is 1. So m is 1, which is option 4. Maximum area is half, which is option 1. Y naught is 1. Y naught is 4, which is option 2. And y1 is 2, which is option 3. Yeah, so 4, 1, 2, 3, which is option A. So this completes solutions for the 2013 JEE Advanced Maths Paper 2. Thank you.